Hey guys, Mr. Myesis here, and today I want to talk to you about linear piecewise functions. So, linear piecewise functions, and these are piecewise defined functions that only have lines involved. You could do more than just lines. You could do all kinds of crazy curves that you can do with linear piecewise functions. But today I'm just going to show you how to use lines and what a piecewise function looks like. So, a piecewise function is a function, well, that's broken up in pieces. It's kind of nice because we can make all kinds of neat pictures with piecewise functions. So we really have, I have two examples here. I've got two more for you, and you can, I would suggest at any time during this video, you should try to pause it, try a practice problem out, and then see how I do this for, how I graph it. So, all we're going to do is graph these piecewise functions. So a piecewise function looks like this. F of x equals, a brace here, one function, x minus 3 if x is less than or equal to 0, 2x plus 1 if x is greater than 0. Now what this does is it takes this line, x minus 3, and says, look, x minus 3, I only want to see you when x is less than or equal to 0. That's it. I want to see any other part of you. Cover it up. Or 2x plus 1 if x is greater than 0. And again, I only want to see that part when x is bigger than 0. So let's go and take a look at what that looks like. So really there are two ways to do this. You can either plug in a point and find out what that line looks like from that point on, or you can graph the entire thing and then erase the part you don't want. So let's look at the second way. Let's do that. So what I'm going to do is I'm going to graph x minus 3. So x minus 3 against just a line, so I'm going to start at negative 3. And then I'm going to go up 1 and over 1. Okay, hopefully you can see that on there, up 1 and over 1. And then I'm going to graph that line. So this is what the graph would look like, the entire line. But I only want that graph at x less than or equal to 0. So I'm going to go less than or equal to 0. Here it's x equals 0. I don't want this part, cover that up, x minus 3, I don't want to see it. I'm going to erase that guy here. And I just want that piece of my graph. Now I'm going to do 2x plus 1. I'll do this in a different color. 2x plus 1, up 1, then up 2, over 1. Normally, this graph would be like that. However, 2x plus 1, I don't want to see you in any other place except for x greater than 0. So x greater than 0, x is equal to 0 here. I want everything greater than 0. That's on this side of the y-axis. So I'm going to erase this part here. And this is greater than, so we have to make an open circle. Okay, so we've got an open circle here. Okay, so this is our piecewise function. That's the way it looks. Again, it's pieces of a function. That's why it's called piecewise. So that's one way of doing it. The other way of doing it would be to plug in 0 in for x. And we're going to get 0 in for x, which would give me negative 3. That would be my y value, which is down here. And then I'm just going to draw that line less than 0. Of course, I'm going to need to use a slope to find another point. And then I would do the same thing here. I'll use that method for the next problem. Okay. So the first method here is to draw the whole thing and then erase the part you don't want. Now this is a thing. This is really important, guys. And it really gets me irritated when my students do this. They put in a graph that has the lines just keep going all over the place. Now, this is a piecewise function, so it needs to pass the vertical line test. So if you draw your piecewise function and you're done and you say, I think that's it, I think I got it. But if you use the vertical line test and it doesn't pass the vertical line test, then you did something wrong. Go back and do it over again. Okay? Make sure this passes the vertical line test, right? It is a function. Let's take a look at another example here. And this time I'm going to use the other way. So what I'm going to do here is I am going to plug in I consider this my end point for this part of the function. So I'm going to plug in negative 2 in here for x. So if I plug negative 2 in here for x, I'm going to get 1/2 times -2, which gives me -1. Okay, this is g of -2. I'm plugging in -2 in for x. So my y value at x equals -2. So at x equals -2, I'm going to have down to -1. It's a closed circle. Now I'm going to graph this line when x is less than or equal to -2. So that means on this side of x equals -2, I'm going to graph that line. So my slope is 1/2. So I'm going to go down 1 and over 2. And I'm going to graph my line. It should be a positive slope, right? Now I'm going to do the next one. So this one has 2 endpoints. I'm going to plug in -2 here. G, well, you know, it's not really g of -2 because it doesn't exist for that. But I'm still going to plug in -2 to see where that point would be. -2 in here is going to give me -4. So -2, -4, 1, 2, 3, 4. Okay, and this is going to be an open circle. Now let's go the other endpoint. Plug in 0 in for x. 0 minus 2 is -2. So I'm going to have 0, -2, which is right here. This is another open circle. And I'm going to connect those 2 points, and that's my piece of that part. Okay, now I'm going to do it for the other one. I'm going to plug in 0 here, and I'm going to get 0 minus 2, which is -2. Oh, that lands right on the same spot. So I'm going to go ahead and shade that one in because it landed right there. And then all I have to do now is use my slope. Go up 2, 1, 2, and over 1, because my slope here is 2 over 1. Up 2, over 1, draw my line this way. Okay? So I have piecewise defined function. All right, so I've got 2 more for you. Go ahead and I'm going to write this next one here as fast as I can here, so I don't want to waste any time. And I want you to maybe see if you can try this out. X minus 3 if x is less than or equal to 0. 2 if x is between 3 and 0. And -x plus 5 if x is greater than or equal to 3. So go ahead and see if you can try that out. Go ahead and graph it, and then I'll give you one more here. One more for the road. Okay, this is number 3. Do number 4 here. And so while I'm writing number 4 down, you can do number 3. And -1 between this and 1/2 x minus 2 when x is greater than or equal to 2. All right. Okay, so here we go. All right, here we go. Boom. Let's graph this sucker. Use whatever. Oh, look at, I'm now on the screen. Use whatever method you want. I just like using it on this side. I'm going to go ahead and just graph these out here. Let's go ahead and graph this out. Plug in 0 here. We're going to have 0, -3. 0, -3 is down here. And then I've got a slope of 1. I'm going down 1 over 1. Okay, and it's going to go like that. We're on this side of x equals 0. Now between 0 and 3, my y value is 2. I don't have an x in there. That's a horizontal line, right? Horizontal line at 2 between 0 and 3. So 1, 2, open circle here. 1, 2, 3, open circle here, horizontal line. Remember, y equals 2 is a horizontal line. Plug in 3 here, and I'm going to get 2. Well, that's nice, because that ends up in the same spot. And then I have a slope of -1, so I'm going to go down 1 over 1, down 1 over 1, get my next point. And there's my piecewise function. All right? Nice, crazy looking thing there. Let's take a look at this one here. And then we're all done for this video, folks. Join me in my next video when I go over something other math related. Okay, so we're going to plug in. We're going to go and plug in -2. So I kind of like this method, the plugging in the point here. Plug in -2, and we're going to get -4 plus 3, which is -1. So -2 and -1. right here, and that's going to be a closed circle. I'm going to use my slope, go down 2 over 1, down 2 over 1. Graph my line like that. Okay, it's a positive slope, right? It goes up. It's positive slope. -1 between -2 and 2. So -1's right here, and between -2 and +2, I'm going to have a horizontal line. Open circle on this one. This one I'm going to stay shaded because it touched the other one. It was already shaded, so it's part of our function. Plug in 2 here. That's going to give me 1 minus 2, which is -1. We'll look at that. We're back to our -1 here. So 2 -1. We're going to shade this in, and then we're going to use our slope to go up 1 over 2. So up 1 over 2. Another point. And there we go. Okay? So, piecewise functions, you can do a lot of cool things with piecewise functions. There are actually a lot of applications we see in real life math with piecewise functions. So maybe sometime I'll put a video on that, okay? Or maybe my students will put up a video on that. We'll see. See if that's extra credit. Okay, thanks for joining me today. See you later, guys.